Okay, so I wanted to show you how to do this in the calculator. So if you go menu, calculus, numerical integral. So we can just type this stuff in. So you've got 0, tab, 2, tab, and then control division, 1 over 4 plus x squared dx. Oh, whoa, sorry. dx. It does it, but yeah, it does it like this. So that's not super helpful, actually. But you can check your answer, I guess. Anyhow, it's the same thing with the pi. This is where they get you. But you can solve these as well. So like this one, we can do and solve. So menu 3, 1, and we want a numerical integral. And I can't do I need to clear my calculator. So c to c squared, and then we have control division 1 over 1 plus x squared dx, and that is going to be equal to 0.22, and you want to solve for c. So that is one of them. And then if you want the other one, you go to this and you can do comma and then just put negative 0.187 like 2. Oh my goodness. Seriously. Sorry. So we want just like that, actually. So that gives you the next one. Sorry. So those are your two values. Sorry, I'm just seeing that a has to be greater than 0. So we need to actually click this, delete that, and start at 2.0, like 5 maybe. Yeah. So there's your two answers, greater than 0. Okay, so for this one we need exact form. So we've done one similar to this. So I remember we made u e to the x. So du dx is e to the x. So dx is du over e to the x. So we'll have 0 to natural log 3, but we leave this e to the x as e to the x. This is u squared plus 9, and du over e to the x. So those cancel. And now we have 1 over u squared plus 9 du. This is arctan. So we're going to have 1 over 3 arctan u, which is e to the x, over a, which is 3, and that we want to evaluate from 0 to natural log 3. So we have 1/3 arctan e to the natural log 3 is just going to be 3 over 3, which is 1, minus 1/3 arctan 0. So just to recall, that is the 0.10. Remember, it's just here from negative pi over 2 to pi over 2. So this is 0, so that whole second term goes away. And arctan 1 is here at pi over 4. So that's pi over 4 times 1/3. So pi over 12 is your exact answer. So the other way to do this here, instead of turning it back into, instead of turning it back into x, what we can do, and what I probably should have done, is change the limits. Okay? So here we want, because u, it's in terms of u. Okay? So we want to know when u, so u is e to the x. So if x is natural log 3, this upper limit, u is going to be e to the natural log 3, which is 3. So this would go here. And if the lower is 0, we'd have e to the 0, which is 1. So that would go here. So then here we would have 1 over 3 arctan u over 3. And we'd evaluate that from 1 to 3. So that's going to be 1/3 arctan 1, 3 over 3, minus 1/3 arctan 1/3. Arctan 1 is pi over 4. So this is pi over 12 minus 1/3 arctan 1/3. Okay, we did not get that over here. Which we should. Oh, because I just did, I see. So I did e to the 0, 0, like very irresponsibly. So that is e to the 0 is 1. So, okay. So you can either change limits and stay in u, or you can leave the limits and go back to x. Okay. So now 45, we have, using substitution. Okay, so dx d theta is 2 cosine theta. So we have from 0 to 2, 4 minus 2 sine theta squared dx is 2 cosine theta d theta. So now 0 to 2, factor, well, it's 4 like this, and then factor out of 4, and it's going to be 1 minus sine squared, which is cosine squared. So now we've got square root of 4 is 2, so this is going to be 2 times 2, so that'll go out here. Square root of cosine squared is cosine. Cosine times cosine is cosine squared. And now we need to get away the cosine, so we know cosine 2 theta is 2 cosine squared theta minus 1. So cosine 2 theta plus 1 over 2 is cosine squared. So if we take the 1/2 out, that's 2. 0 to 2, and we've got cosine 2 theta plus 1 d theta. And that is going to become sine 2 theta over 2 plus theta. And we're evaluating that from 0 to 2. No, we are not. Because this gets messy. Because we went like here, all of this is in terms of x. So all of that is x. So what we need to do is 2 upper limit equals 2 sine theta. We need in terms of theta. And 0 is 2 sine theta. So sine theta is 1. So here, sine is 1 at pi over 2. So this is actually going to be pi over 2. All of these are pi over 2. And then here, sine theta is 0. And sine 0 at 0. So actually, all those will stay 0. Okay, so that's fine. All right, so now we can do pi over 2 and everything. So we've got sine 2 times pi over 2 is pi, then over 2 plus pi over 2, minus, when we substitute in 0, so sine 0 is going to be 0 plus 0. So that's just all 0. So sine pi is 0, so that goes away. So we're just going to have this is equal to pi. Now here, we could have gone back to x, but then that's got arc sine, and like this would become 2, then it's going to be 2 sine theta cosine theta, 2 sine cosine over 2 plus theta. And this, well, we'll deal with the limits in a second. Those cancel. Sine theta is x over 2. Cosine theta now, cosine theta, so sine theta is x over 2, so we're going to have x squared plus y squared equals 2 squared. And then y squared is 4 minus x squared. So that's that. Plus, so that's sine theta cosine theta. And then theta is going to be arc sine x over 2. And that we would have to evaluate from 0 to 2. Okay? So we would have 2 over 2, which is 1, root 4 minus 2 squared, which is 0. So that whole first thing is 0. And then arc sine 1. So arc sine 1, when is sine 1? That's pi over 2. So then we minus when we substitute in 0. So that first thing is going to be 0 again. And plus arc sine 0. And that's going to be at 0. So we still get pi. So I think that just, it's easier to change the limits. Okay, 46 now. We have 0 to 1/2 of all that is that. That's without calculator, because you could use calculator for this, but. All right, so x is sine theta squared. So dx d theta is 2 sine theta to the 1 times cosine theta, which is sine 2 theta, which we probably won't use. So now we have the square root from 0 to 1/2 of the square root of sine squared theta, that's x, over 1 minus sine squared theta, which is cosine squared theta. Dx, which is 2 sine theta cosine theta, we're not going to use that, d theta, and that's equal to pi over 4 minus 1/2. Okay, so again, we need to change our limits. So 1/2 is going to be sine squared theta. So I'm going to erase this. And 0, I'll put that here, 0 is sine squared theta. So sine theta 0 Well, that's just 0. Theta 0 here. And then we've got sine theta is the square root of 1 over the square root of 2, which is actually root 2 over 2, right? Plus or minus root 2 over 2. So we will have pi over 4 because it's 1/2, right? Yeah. So this is pi over 4. Okay, so now 0 pi over 4. This is square root of sine squared is sine, square root of cosine squared is cosine, and then we can cancel the cosines, take out the 2, and that's going to be sine squared on the inside, d theta. And then we have that cosine 2 theta is 1 minus 2 sine squared theta. So cosine 2 theta minus 1 over negative 2 is sine squared. So taking out the negative divided by negative 2, that's going to be negative 1. And sine, okay, yeah, and this is cosine 2 theta minus 1 d theta, pi over 4 minus 1/2. Okay, so then this becomes sine 2 theta over 2 minus theta, and that's 0 to pi over 4, and the negative 1 I'm going to go to the other side, so that's going to be 1/2 minus pi over 4. So then we can, what are we doing here? Show that. I was going to say, like, we're going to get down to, okay, so I didn't need to include literally writing all of this. Anyhow, so now we have sine 2 times pi over 4 is pi over 2 minus pi over 4. And then we would subtract when we substitute in 0, but that's just going to be 0 for both terms. So now sine pi over 2 is 1 over 2 minus pi over 4. Check. We showed that the left side equals the right hand side.